So, when we do box and whisker, we talked about yesterday, even though the box might have different sizes on each piece and your whiskers, one may be really short, one may be really long, we've still got a quarter of the data on each one of them. So, we talked about the 5 points, our lower and our upper extremes, the very least and the very maximum point, my median, the number in the middle, my upper and lower quartiles, we call them the first and the third, but basically it's found by just taking the median of my lower and my upper parts, and we're going to do that again today. And then this just goes back through everything we're going to do, but I'm not going to read all of that to you because we're going to be doing it here in a moment anyway. So here's what our deal is going to be. And this is going to take a minute, but we've got this. We're going to draw a box and whisker plot comparing the quality rating of peanut butters. Now, on the back of the sheet is a whole big old list here. Now, the only column we care about paying attention to is whether it's creamy or it's chunky. So, my first job is I am going to go through, and any one that is marked creamy, I am going to put a dot next to those because that's going to help me. Well, oh. Yeah, in this column here, it either says creamy or it says chunky. For the first part, we're only going to be working with the numbers on the creamy ones, and I almost got a little happy here and did a chunky. So the first group here is kind of creamy, and then it goes chunky for a while. Let's see here. Jif, we go creamy again. So I'm just going to put dots next to the quality rating number in my creamies, and I think that's the end of them here. So I'm going to get those dotted, and then this is the part that gets a little more tedious. Once I have those, I need to get those numbers and put them in order. Now, here's the part about that where I would definitely make a suggestion. And my suggestion would be either to write the numbers down and then order them, which isn't a bad idea, or you can start from the bottom and then just flip back and forth, crossing the numbers off. Now, normally, I would put you through something like this, but today, since I don't want to drive you crazy, I am going to help. So, for the time being, we are going to flip back to the other side. And I, being the nice person I am and that it's Friday, am going to not only give you the numbers, I am going to have them in order for you. So, I just wanted you to see what it would be like if we actually had to deal with all that stuff. All right, so under creamy, this list is going to get a little sizable here. Let's make sure I'm in the screen here. Give myself all the room we can. All right. So we've got 11, 23, 31, 33, two 34s, 35, 40, 43, holy cow, 52, 54, 57, 3 60s. Ooh, I am going to fit. 69, 71, and thankfully the end, 76. And again, these are my creamies. So once I get those, if I'd have gone through the chart and I'd have found all the creamies, then I'd have gone through and I'd have put them in all in order. And again, if I was doing that myself, I'd have just looked for the smallest number, I'd have put a mark through it, and I'd have just flipped back and forth. That's what I literally did when I was putting this list together. So now, whenever I'm trying to find all my values, because we just did step number 1, now we want to find the median next. We want to find the number in the middle. Oh, on it already. All right, 43. Because again, if I wasn't sure, I would just keep moving in from the edges one by one until I came to the middle. Okay, so that is my median. So my median is 43. So now, like we did yesterday, to find my lower quartile, or my first quartile, all of those numbers up until my median, I need to find the median of that group.
What's that word say about the green line? What's that say?
This word?
Does that say creamy?
Yes.
Oh, okay.
So now that I'm looking at this group, I'm just doing the median thing again, and that's going to give me my lower quartile or my first quartile. You can talk about it in either word. So I'm like, okay. So I start at the end, start working my way in. Find the number that's in the middle. And that's my lower quartile. And then I do it one more time with all of my values after, and especially with seeing that many 60s, the likelihood, even before we started, of thinking that it was probably going to be 60, which would be my third quartile, okay, is pretty obvious. And then actually, as soon as I have my list done, I could find my extremes. My lower extreme is just the smallest number, and my upper extreme is the biggest number. So when I go to make my box and whisker plot for this, just like we did yesterday, there's a couple of things I want to keep in mind. So for instance, do I want to use their line? Yeah, that's actually not a bad idea. I'm going to use their line. So here's how I'm going to use their line to make this work. We're going to put both of these on 1 so we can kind of check this out. My lowest number is 11. My highest is 76. Now with the next one, my highest number is going to go up to 89. So I'm going to count by...
Did you say what the chunky variance, like, highest is? Did you say that?
Yeah, I was going to say, we're going to do the chunky one still, too.
So I thought you were going to do both, like, the, because it's the smallest one, you do the one.
Yes.
Why don't you look at the chunky one?
All right, let's do both of them before we draw. That's probably not a bad... That's a good idea. Let's get all of our stuff done before we start drawing pictures. I like it. So let's go back here. I will give you the chunky list. That is a good thought because, yeah, if I went ahead and made my extreme and then, oops, the chunky one was bigger, I'd be kind of screwed up. So, all right, here come the chunky ones. The chunky ones were a little higher quality to begin with. So 26, 29, 31, 34, a couple of 40s, 40, let's see if I can read my own number, 49, 54, 57, 63, 67, 69, 69, oh, Hardy, you got to write smaller, 83, 83, we're going to be looking for the same info. Yep, here again. We're going to be looking for the median.
No, that's a mean. What does it mean?
Means an average. So once I get all my chunkies, I'm going to go through the same process I did with the creamies, except this time you're going to find out when you get to the middle that it turns out a little bit differently. Nicely done. So I start counting towards the middle.
Didn't you add it and divide by 2?
Yeah, because I find out this time I have 2 numbers in the middle. So I have to add those up, which would be 103, and divide by 2. And yes, you absolutely can get a decimal. So I've got my median. Whew. Now, remember, when I go to split these, since I have 2 numbers in the middle, that first number is going to get included when I'm looking for my first quartile. And when I look for my upper quartile, that second number in my median is going to get included. Okay, Okay, so no numbers will not be used this time. Everybody's going to get used up. So I start going. I'm like, okay, so I start here and here. One number in the middle. So we've got ourselves a 40 for our lower quartile. All right. Coming in. Same spot. 69. And yes, it was smart to wait in this case before we drew, because as the initial concern mentioned, my lower extreme, my upper extreme though definitely is bigger than my upper extreme was with the creamy. So now that I've got all of my data, now it doesn't mean I'm going to make one box plot out of this. I'm going to make two, but I'm going to use the same scale, which is good because then our data is all working off the same idea. So let me center this up a little bit so where we can still see our data, but we can see our line. Sure.
On the first one, I remember, like, on the 46.
Uh-huh.
I thought they both crossed out, so I don't know.
Well, let's see here. All right. So if we start with these and start working our way in.
Why? I'm so confused.
Now, did you start at 49 on the right side?
No.
That's the difference. Yeah, when there's two numbers in the middle for my median, that first number I used goes with the left part, and that 54 is actually going to go at the right. So if there's only one number in the middle, like there was with our creamy, then we don't use it. But otherwise, we have to use those. So that's probably what got you there. So I'm glad we got that straightened out, because we got it on here too now. So now, all right, so my lowest number is at 11. We'll start a little lower than that. Let's say we start at 10 down here. My biggest number is 89. We'll go a little above that, 90. And I'd say let's just go by tens. That should get us 20, 30, 40, 60, 70. That's about right. And if you wanted to go by 20s, 10s, 2s, 5s, again, as long as you're consistent, it doesn't matter. You can definitely do it either way. And then what I'm going to do is we're just going to make two box plots. We'll make them on top of each other, like one down and then one up a little higher, so we can visually see some of the differences and things. So all right, we'll start with creamy here. So my 3 dots that I'm going to make right away, okay, I'm going to make lines at those 3 places. So at about 33, at about 43, and again, it doesn't have to be perfect, but kind of close. And then one at 60. And those 3 lines will make me a box. And once I have that box, then I just use points for my lower and upper extremes and just connect out, and those make my whiskers. But like we mentioned up at the top of the page, and I just wanted to make reference to this again, 1/4 of your data, 25% of my data would be covered in each of these places, even though my whiskers don't look like they're necessarily the same length, and my box certainly doesn't, but that's where portions of the data are, so I can figure out where a lot of the data is or where not a lot of the data is. Uh-huh. Yep, for every piece it's always going to be 25. So that would be my box and whisker plot for my creamy. And then for chunky, we'll do it in a different color here. Same idea. My quartiles and my median, we're going to put those in first. So, bless you, we've got one at 40, 51.5. Down here at 69. So we'll get our box down. We notice this time our box is further to the right, which would tell me overall the quality of the peanut butter seems to be better with the chunky brands. And then I got a dot down here at 89 and one back at 26. Get my whiskers in. So if you had a question like, which type of peanut butter seemed to have better overall quality. Well, we could look at this and see that my chunky, okay, even the bottom part of my chunky is almost as good as the middle 25% of the creamy. So, I mean, there's a lot of things you can get looking at this that I wouldn't just looking at all those numbers on that chart. I mean, charts are nice, but being able to physically see what's going on here is definitely helpful, okay? So again, this is deemed a note sheet. This is something you can use when we get to the quiz next week. If I had you say draw a box plot, you got all the steps even written here for you on this side and an example, so it's pretty good. So now, we're going to take this idea and we are going to jump into the box and whisker plot worksheet, day 2. So let me move this out of the way. There is going to be an extra credit part in this worksheet, which I will get to momentarily.
What is the percent of your class score?
Ah, okay. Well, let's do 2 things here. Let's answer number 1, and then I will answer that percentage question for you. What was the highest score somebody got in this test? Close. Maybe this is confusing because we're not seeing dots on the ends here.
102.
Yeah, my dots at the end are my little lines because they chose to use lines instead of dots at the end, are my extremes, so somebody rocked out 102. Not bad. Not bad. So, what percent of the class scored above a 72? Remember, each portion of my plot would be 25% of the class's scores. So what percent of the class scored above 72? What percent is past that 72? Just add up your 25s that are after. Yeah, 25, 50, 75% of them. So that's the important part about remembering with a box and whisker that each part's worth 25% because your answers always be 25, 50, 75, or 100. They just break down that way. What's the median score on my test? What number's in the middle of my box? 88. You're like, well, it's not right in the middle of my box. No, but that's the score that would be in the middle if I had all the data. And then what percentage of my class scored between, 88 and 96, 25% of them. So now I should be able to take something like this and get into questions like 5 and 6 and be able to intelligently discuss this. Do you think this test was too hard for the students? No, I agree. Why not?
There was 75% of students that.
Yeah, 75% got a C or better. I mean, they got over 72. If you really want to look at it, 50% of them were at 88 or above. They almost half of them got A's. I mean, yeah, I don't think that's too hard. I think it might be the other way if nothing else.
Hey, we just gotta explain if we just don't know. So, that's a no.
I want you to actually think about it a little. So, as I kind of keep going here, I'm like, okay, so then would I expect the mean, would I expect the average to be above or below the median? So do you think the average score would be above or below 88? Right, I'd have half the scores, that's true. But where do you see a bigger portion of your graph at? Above or below the 88? Below. So, there's more scores below. It doesn't mean when I'm looking at the total, it just means the average score. So I would think that my mean would be below because I have a bigger range of scores that are below 88, okay? With that bigger range of scores, I should say that, more of a range of scores below 88 because it's not more scores because it'd be half of them. Okay? But wherever you see a bigger piece of your graph, that's where a bigger piece, or more likely where your mean is going to be. So that kind of gets me thinking about this a little, and I'm trying to think of the specific ones I wanted to look at with you, because I want to do a chunk of these with you. All right, let's jump to the back of this page for a minute. We're going to bounce around a little bit here. Let's move to the 12 through 23 part with the TV and homework minutes per night here. Okay, we got two box plots we're looking at. We got one that talks about the time that's spent on homework and the amount of time that's spent on watching TV. So again, remember, even though they've got the lines here, these are actually my extremes. So I'm just going to put dots on those to remind me. Wow, that's an extreme. 225, that's almost 4 hours. Whew. So, when I'm looking at these, okay, so on 12, for instance, what percent of the sophomores watch TV for at least 15 minutes a night? So let's see here. If these are all, even this little guy here, so at least 15, so 15 or more. How much of my chart would that cover? 75, because if it says at least 15, it starts here and would go all the way to the end. So that gets 3 of my 25s. So 75% of them. What is the third quartile? Okay. What is my upper quartile for TV time? Because remember, it's always median in the middle. Yep. My third quartile is always the one on the end. And my first quartile is always the one at the beginning. So absolutely. 110. So now we kind of, once we get the basic data, now we start to actually try to apply it and actually have to think a minute. So let me get the box plot up here where we can see it. Is it more common for a sophomore at this high school to spend more than 1 hour on homework or more than 1 hour watching TV? Okay, I agree. It's watching TV. What percentage of the students spend more than an hour on homework? On TV, yes. If we're looking at more than an hour, if it's on homework, it would start here and go. So 25% spend more than an hour on homework, according to the graph. But when you find 60 on the TV, ooh, I got 2 chunks of 25. Okay, 50% of them spend at least an hour on the TV. That's as legitimate as you can be. You're explaining where your answer is coming from by using the data right off the graph. Okay? And this is what people do all the time for a living, but it's also why you can make data basically say what you want. So now at the bottom, there's just some true-false questions that go along with my plot up there. Okay? So for instance, number 15, we'll do the 3 that are on this page. Some sophomores didn't watch TV that month. Yeah, because TV time, I've got a spot here for 0, so that's true. The TV box and whisker plot contains more data than the homework graph. So does that mean they talk to more students with the TV time one? Or does it just mean that the answers they gave are more stretched out? So see, here's one thing with a box and whisker that you can kind of help to learn too. You're not sure because A, they don't tell us how many got interviewed. But here's the one thing. Let me come down here for a minute. There's one little bit of info. Okay? The same group of sophomores, the exact same number of people got surveyed. So the exact same number of data is in each. You're like, well, how is that possible though? Because this is a lot bigger. They might have told a whole bunch of different times. You had some people saying they didn't watch TV at all. Some were watching for almost 4 hours. Some were watching for about 2. And you'd see that with the data. Same number of people, just a little more of a togetherness in how much time they spend on homework, which isn't a whole lot here, and a whole lot more time spent on TV. So just little things could help us with that. 25% of the sophomores spend 48 to 60 minutes a night on homework. Let's see, homework, 48 to 60. Yep, that'd be a quarter of them. Okay, so that one's going to be true. So I can use the chart to help me figure out this information if somebody was to ask me, and I can be intelligent about it. So, cannot be determined. Instead of writing it all out, I just use the initials. All right, let's see what else is in here. Yes, I'm thinking maybe I'll help on that one. Ooh, I'll do this. Yes. Okay. Let me mention a couple of things on the inside. I'm going to help with 26. We're going to do some box and whisker in here again. And we're actually going to work on the data together. Once you get past that, okay, 27 through the end, 27 through 35 is extra credit. Okay? So that'll kind of lay back a little. But again, if some of you are looking for opportunities to get some extra points that some of you need, and will ask me about sometime during the term, there's your chance, okay? So 27 to 35 is easy. It just has you make up a couple of box and whisker plots and answer a few questions. So if you're looking for an extra assignment, there's a way to do it. All right. So in the table below, the average monthly temperatures for Pullman and Seattle are shown. Draw a box and whisker graph using the same scale for each city from the data. So sort of like what we did with the creamy and chunky peanut butter. Then write a short paragraph, sentence or two is okay, summarizing what the graphs tell you. Okay, let's rock. Now this time, I don't have everything done ahead. So we're going to have a little bit to play with here. All right. So Pullman, we need these numbers in order. So let's see. What's the smallest number in my Pullman list? 34.5, the first one. Okay. So we are going to start listing these off, and I'm just going to cross them off as I go. All right, what's next? December, so 35.9. With it being at temperatures, you can kind of figure where a lot of them are going to be. So February looks to be next. November. March. April. Oh, I'm going to run out of room. I write too big. Because I want to make one list. Oh, well. We'll make it work. May. We'll just do Seattle above. June. September. And I got to take my time, especially because I'm using a pen, not the wisest thing for me to do. And August. Okay. So once I get those listed, and again, Pullman we got down below here. We're going to start from the edges. And in we come. And I'm like, oh. So let's see here. We've got 2 this time, so we are going to, as always, we're going to add those 2 up. And we're going to divide by 2 because we want their average. So yeah, we can get some kind of funky numbers working here. So 57.85, and now I just took up my Seattle space because I wrote above. Uh-oh. Oh, well. So then, again, when I'm looking for my quartiles, that first number for my median, that 55.9, gets included in my bottom half. And the 59.8, that first number, that second number in my median, gets counted in my upper half. Man, it's just not my lucky day here. Yep, I'm going to get stuck. So again, we'll add them up. We'll get that out of my way here. Add them up. Add them up. Add them up. And divide by 2. And one last time. And that one actually comes out even.
Calculator's on the way.
All the calculators in the way. Thank you. And we come out even. Straight up 72. Now let's see. Where am I going to put Seattle? I'm just going to rewrite Seattle below here. Get rid of it here. And we will start up again. So, all right, Seattle. Top one. All right. So 44.7. Let's see if it kind of just swings back and forth like the last one did. 50.1. 52.0. It is. It's almost just nicely swinging back and forth. Whoops. And then I get to April. 61.3. Gets a little bit tedious, but the information we can get from it is more valuable than the info we would get just by looking at charts in general. All right. And again, we know we're going to have these double ones again because, again, it's 12 months for each. So I just know that's going to happen. So let's start working our way in here. All right, that one is not going to come out nice. Let me get the calculator out of the way here. So let's see, add them up. Divide it by 2. Then we will swing the calculator over here. Because again, that first number in my median gets included in my lower half. Whoops. And the second number gets included in the upper half. So let's see here. These two guys here. I think it's going to be 51.05, but it's Friday. I want to be sure I'm doing this right. All right. So 51.05. And we'll swing it over. This one I definitely can do on my own. 71.1. And then I just remind myself of my extremes at the end. So I look, and I'm like, my littlest number for both lists is 34.5. My biggest number is 81.9. So to me, it seems sensible to start at 30. And let's go to 90 here. 40, 50, 60, 70, 80, 90. My lines aren't perfect in spacing, but it will work. So let's see. Let's do Pullman first here. 57.85, so pretty close to 60. 42.1. 72. Make my box with my first, middle, and third quartiles. And my minimum's at 34.5. My maximum's at 81.9. And there is my Pullman box and whisker. And we'll play again up here. So let's see. Oh. Anybody notice my boo-boo? Or did I not boo-boo? No, I didn't boo-boo. Okay, never mind. I thought I did mix this up, but I was doing Pullman, so I actually did that right. All right, so Seattle. We're just above 60, just above 50 here, just above 70 down here, 72, so we're a little further. Oh. Boo, Hardy. I think I jinxed myself into boo-booing when I talked about it. Another reason not to use pen. Seattle is 71.1. That's a little bit shorter than that one was. Okay. So Seattle, my minimum here was in the mid-40s. And my high, 76.9. Out in there. I'm going to get white out on my pen. That would be Seattle. So once I had those two pictures in front of me, what could I make? What kind of general statement could I make about the temperatures with Seattle and Pullman? Or is there nothing I can take from this graph? You say nothing. If you wanted to be in an environment where the temperature was pretty settled, pretty close to being the same thing regularly, which city would you rather live in? Okay, Seattle. If, let's see. So that's one thing we could say. Seattle has, let's say, less extreme temperatures. Oh, what else? Let's see. That even, and I know it said a paragraph, but even something like that in general, just to show it's like, okay, I've thought about this a little, that. Or you might say, I like Pullman because I like to be cold sometimes, I like to be really warmer sometimes. That'd be fine too. But that's where we're at as far as this goes. We're trying to kind of work it that way. So, your job